cloud එකේ දාපුවම share කරගන්න ලේසි.
Okay.
එනම් ඔන්න පටන් ගත්තා right?
Sure.
A very good evening to all of you, ladies and gentlemen. We are gathered here to listen to Dr. Amila Wickramasinghe, the Energy Management Forum, a monthly event organized by the Sri Lanka Energy Managers Association. This is Harsha Wickramasinghe, President of the Sri Lanka Energy Managers Association. And today is going to be a very exciting event because it is one of the hot topics discussed in the country. Especially there are many groups of people who lobby for different generation options in the country. Some are for coal, some are against coal, some are for renewable, some are less favorable for renewable energy, and there are many views and many aspects. So we have a very good presenter, Dr. Amila Wickramasinghe. Unfortunately, he's away from the country. He's now located in Australia. Due to the pandemic situation, he couldn't return to the country as planned. And to give him a brief welcome and introduction, I invite Mr. Rasika Gamugi, our senior secretary.
Good evening, all of you. Yeah, you all are welcome to the 36th session of Energy Management Forum on conventional generation or renewables, power system planning perspective. I repeat again, conventional generation or renewables, power system planning perspective. Today, our presenter is our dearest colleague, Dr. Amila Wickramasinghe. It's a product of University of Moratuwa, specialized in electrical engineering, masters in economics from University of Colombo, and also director of SLEMA board. You're welcome to the session, conduct the presentation, Dr. Amila. His expertise in the field, and I think you can gather a lot of knowledge through the presentation. Presentation would be 40 minutes. On the chat, through chat or Q&A, or else you can raise hand and will be taken up during the discussion session. Over to you, Dr. Amila Wickramasinghe, to conduct the presentation.
Thank you very much, Mr. Harsha Wickramasinghe, the President of SLEMA, and Mr. Rasika Gamugi, Seminar Secretary. Thanks for giving me this opportunity. And I welcome all of you to the Energy Management Forum of SLEMA, which has been going on very well for so many years. And today, I finally got the opportunity to present because I was away. I could not join earlier. And I have selected this particular topic with the idea of actually not presenting a particular theory or kind of a process as such, but more to discuss among ourselves, the energy managers and the SLEMA members and the guests, about a very pertinent topic, debatable topic, and to get different viewpoints, and to kind of initiate that process of the discussion. I will present the planning perspective, because it would be good to know what the planners would be looking at. I myself, I don't consider myself a planner. I'm almost a third party in this the process, but I would like to kind of discuss how the planners would be looking at it, and why we the others think of this issue as to, whether we should take up more renewables or whether we should go with more conventional energy. Different people have different viewpoints. So let's look at one angle first, and then try to collect the other angles so that we are better informed and appreciate the viewpoints of the others before we actually make judgments on, certain performance of utilities, performance of businessmen, and so on and so forth. Okay, so the context I would like to, discuss this topic on are, these are, questions we all have in our minds. Is sufficient support is provided or given to renewable energy? That is one main question most of us have. If not, if we think that, okay, renewable energy is not given enough opportunities, especially in Sri Lanka, what could be the reasons? Most of us have that kind of a view that, okay, there is not enough opportunities given for renewable energy. So are there valid reasons for that? Does renewable energy warrant more support opportunities? Are there, valid reasons to support renewable energy? What are those? So that is another thing I would like to talk about today. And also, what about conventional generation? So most of us, or many people nowadays don't think that conventional energy is the future. Okay, so or are they getting special preferences? Conventional energy like coal power, even diesel power. You hear of diesel mafia and all this. So are they getting special preferences? So on the other hand, undue opposition. So let's discuss, whether these questions are valid, whether these questions are shared by all of us, and whether there are reasons that could justify the answers to these questions. And today, of course, I will try to present one angle of this problem, but let's share different viewpoints, your views on this. So I will try to leave enough time for us to have a good discussion, more than a presentation by one party, because that is the objective of having the energy management forum. At the very beginning, we decided on having this kind of a thing, not as a presentation, but to, catalyze some discussion on a particular area, so that SLEMA members, SLEMA kind of allows everybody's views to be shared with others, so that everybody gets more, knowledgeable on a particular area. So that is the objective of today's energy management forum as well. And through these questions and through the, the initial discussion, I would start. Let's try to share that, the different understandings of the problem. So first of all, let's see why we should be using renewable energy. And here I have listed down several reasons. One reason, the low capital cost, which is expected to reduce further. We have seen some technologies like solar, the costs maybe comparing with 5 years, 10 years back, today's solar prices are so low. And it is not even, close to reaching the rock bottom. It is expected to go further down. Okay, so that is one good reason for us to use renewable energy. Then the operational cost, there is no fuel cost at all, or some technologies have fuel costs, but not very much. So either zero or very low fuel costs. And another good thing, especially these days, we are saving so much of foreign exchange by not even, spending on importing vehicles or many other things. So renewable energy is ideal for that, because it saves foreign exchange. At least we don't have to buy fuel over 20-30 years. So that saves a lot of dollars for us. And then exposure to the exchange rate variation, that is another issue. Like, we may think, okay, this is the cost of say diesel or whatever, but who knows in 10 years time what would be the price of fuel. So that exposure gives us a lot of uncertainties. So when you have a renewable resource, the good thing is, you know that there won't be such big, outflows of dollars from our country, because we don't have to spend money on fuel. It's only the capital cost, which we know is today's price. So we know how much it is. So that uncertainty is entirely gone when you have renewable energy. And of course, we all know that most of the renewable energy sources are environmentally friendly. They don't have that many emissions, no, pollution, or at least pollution compared with conventional generation is minimum. So in that sense, there is a big trend towards, moving towards renewable energy internationally. So not only us, all other countries in the world are moving towards renewable, and there are agreements between different countries like us and other countries that, okay, we will reduce our renewable energy, or we will reduce our emissions and undertake development of more renewable energy. So one such agreement is the national NDCs. So according to the Paris Agreement, we have committed ourselves to develop more and more renewable energy in place of conventional energy. So that itself is kind of a very good reason for us to, start using renewable energy, isn't it? So the good thing or the bad thing about this even the slide is that I may, put this in such a positive way, but there are counter arguments for all of these points. That is what I would like to emphasize, that, okay, one person would think that all of these are correct, and another person could think that all of these have, shortcomings. There are different, situations where these are not correct. So that we will understand, but I will not bring out the counter arguments against this. But if, there are enough examples to show that, okay, this is not the case. But on the face value, let's agree that, okay, these are very good reasons for us to take up renewable energy. But on the other hand, what about conventional sources? They also have very good reasons to be, preferred over renewables. Overall cost is low. As I said, there will be, views, or there would be certain experts who would say that all of these points related to conventional sources I have listed down in a positive manner are not correct. But for the time being, let's assume that, okay, this is the conventional wisdom, that overall cost of conventional energy compared with renewable energy is low. At least that was the case until very recently, that, okay, coal power and certain other conventional technologies were cheaper than, say, wind and solar some time back, and so on and so forth. So that comparison is they are in favor of conventional sources. What are the conventional sources? I take, say, coal power as the main conventional source, because most countries use that, and then diesel generators, heavy fuel oil power plants, LNG power plants, so natural gas power plants, gas turbines, and then even nuclear could be a conventional source. Even our hydros are considered conventional, though they are renewable. It's between renewable and it's a renewable conventional technology. So we'll leave that aside, because we don't have much of a debate about whether we should develop large hydros or not. We have almost saturated with the use. So leaving aside the large hydros, there is a clear distinction in our minds that, okay, there are certain technologies which are renewable and non-conventional, whereas there are certain technologies which are conventional and non-renewable. So the distinction between these two is clear, and we say that there is kind of a preference over one over the other by the planners. That is, kind of a conception we have. So let's see whether there are such real basis for that argument, or whether there are reasons for that. The other thing is conventional technologies. The literal meaning is that, technologies are proven. They are conventional. They have been there for so many years, and they have proven to be successful. Okay, and they are really reliable. In that sense, we know that they are going to meet our requirements. That's a very positive, point or aspect about conventional technologies. Assist in maintaining a stable grid. That also is important, leaving aside the cost and other factors. Say utilities and even us would like to have not a very unstable or rather unreliable system, but we would prefer our grid electricity to be as reliable as possible. I know even some of our you at this moment don't have electricity, not because of renewable or conventional, it is because of some other reason, but still when the system is not reliable and when the system is not stable, it's a problem. So we want to avoid that. Especially planners would like to avoid such situations, and they count on the proven technologies to do the job. That is why that is one other reason why conventional sources should be used. And I have even taken out this photograph. Land requirement is considerably low. This is something we don't discuss that much against renewables, but just look at the photograph over here. You know what the power plant this is. I think this is a Norotchole, and next to it is the wind power plants. Probably you know that this Norotchole power plant, it generates 900 megawatts. Okay, within that space we get 900 megawatts. These three stacks representing the three units, each of 300 megawatts combined gives you 900 megawatts, whereas the three wind turbines would give you about 6 megawatts. Okay, almost the same, the width between these two. This is just a simple example about the land use of conventional energy against renewable energy. Okay, of course there is enough space in between wind turbine, it doesn't matter, but overall we can easily say that the energy density per unit footprint is much higher of conventional energy than renewable energy. That's another factor we should consider in countries like ours, where we don't have that many spare land for energy generation. Instead, we need that for cultivation of our food crops and also for people to live in. So that is a factor we may one day consider important. And fuel costs could reduce further. At the moment, it is kind of a risk factor, but could even turn out to be an opportunity. Nowadays, say many countries, even here in Australia, say though they one of their main incomes is selling coal, they are also moving out of coal. So many countries are moving out of coal or reducing the use of coal because of environmental concerns and global commitments and so on and so forth. So I wonder whether one day there would be so little demand for some of the conventional fuel sources like diesel or coal, that the fuel price could be even lower, not higher. So in that sense, when if we manage to be still using these sources or these fuels, maybe we could get them at a lower cost than today. Never know. And also, though we say that it is environmentally not good, most of the conventional technologies nowadays can manage or meet the environmental requirements. Otherwise, they will not be allowed to run. Even Norotchole, of course, we know that there are problems, but still, when the problems are resolved, when the technical issues are rectified, they run in accordance with the national environmental requirements. Otherwise, they won't be built. So in that sense, we can't say that, okay, they are polluting. Of course, there is some pollution, but not to the extent that we can't bear. This is, and another thing about this particular issue about environment is, compared with our commitments and compared with our, the affordability, to what extent we can just avoid using, if it is cheap, like my first bullet point, if it is cheap, to what extent we can actually rely on the environmental issues alone to avoid using conventional generation. As of now, there is nothing restricting us from using conventional generation. Even diesel we can use if it meets the local environmental and other regulations. So as far as the existing laws are permitting, we can use conventional generation. So in that sense, So the comparison has positives on both sides and negatives on both sides. Okay, so this is our common arguments. We can, have to separate, bias ideas towards this and, argue about that. And that is what we are doing. But now let's look at why the planning perspective is important and how at national level and utility level, these two viewpoints are actually taken into a proper process, and finally, all these factors I just mentioned, positive and negative about conventional and renewable, how they are processed together to come up with a plan. At the national level, it is very clear, okay? Not that many technical issues. It is mostly driven by the desire to have a higher economic growth, okay? Economic development is the main priority of the national planning. So in that sense, national planning or the policy planning, the political level, the administrative level, there the focus is actually to get necessary electricity supply developed to support, to facilitate the desired or the envisaged economic growth, because there is a very good correlation between economic growth and electricity consumption. Higher the electricity consumption, we have seen that higher the economic growth. So in that sense, we know that to drive the economy, we need good electricity supply. So in that sense, following factors we consider at national level in planning our electricity. So this is not the final, technology-wise planning. This is the overall national level planning with regard to electricity. There we have some identified priorities. The first priority is the availability. It's basically to giving all our citizens, the populace, the people in the country, access to electricity. So one target we had was 100% electrification and then access to all. And these targets are one of the key planning criteria used at the national level. We need electricity available for everybody. And then the affordability. That is another target we had, and another target we have, to make sure that all the poor people, all the industries, all the commercial establishments can afford electricity. Improving the affordability of the electricity is the second priority. So for this, cost of generation has to be reduced, price of electricity has to be reduced, and if required, at national level, we are even ready to provide subsidies to electricity or to the electricity sector so that affordability can be maintained. Because we know when the consumers can afford electricity, they will consume more electricity, which will indirectly or directly drive the economic growth. And the third factor is about sustainability. We know that, okay, availability is there, affordability is there, but we need to have that situation going on for more than, the short term. So we need it for the longer term. In that sense, we need these requirements to be fulfilled in the longer term, and also not in pure monetary sense, but we need it to be sustainable in all aspects. That is environmentally, socially, economically, all aspects it should be sustainable. And also there is another factor we usually consider in our energy policy. It is considered the most important, that is supply security. Security of energy supply or the electricity supply is also considered part of the sustainability, that we have a long-term availability of electricity. And then reliability and quality. These two at the national level, we have kind of a general idea about, okay, we need reliable electricity and we need a high quality of supply, but we don't specify that to the, the minute detail, because that is taken up at the utility level. But in general, we as a nation, as a country, at policy level, think that reliability is important. For example, 24/7, that is no power cuts are tolerated nowadays. At the national level, we have come to an agreement that, okay, even at a higher cost, we would still make sure that electricity is available all throughout. And also for that, we will spend necessary money and invest and do maintenance properly, and also invest additional money and keep reserve capacity so that our reliability is ensured. That also is identified as a requirement and a priority by the the policy level, so that the planners can actually comply with that requirement. And also quality, little by little we have achieved all these previous priorities I have mentioned about: availability, affordability, sustainability, energy security, and so on. And even now, I think our reliability focus is gaining momentum, and we are improving our network and reserve capacity and so on and so forth. And finally, once we fulfill all these requirements, finally we would strive to have a quality supply, that is voltage fluctuations, frequency variations, harmonic levels, and all these would be improved in terms of technical quality of the supply, as well as service quality would also be improved. Of course, these days we should understand that there are weather issues and also other issues like the pandemic, that quality is quite low compared with what we used to have. But still, in general, our overall supply quality and all other aspects have improved over the years, because we have been planning our system, and we have providing policy guidelines towards achieving these targets. So even now, these are there. And our most recent energy plan, which is 2019 plan, also specify these, not in the same order, but generally in accordance with these kind of priority areas where the people or the planners who are actually implementing or taking up electricity sector are guided by these, so that they could actually decide on what to do. Okay. So the national energy policy actually gives out the resolution or the decisions taken by us, the people, what we think should be our electricity. If we think that, okay, we should not be spending more on say fuel security, or we should not be spending more on environmental things, then our energy policy would be slightly different to what we have today. Because at the moment, we as a community, as a country, have decided that, okay, we need energy security. For that, we will have a diversified energy supply. We will have renewable energy, so that we compromise perhaps a little bit on the price or the cost and improve the environmental sustainability. Likewise, we have taken a lot of decisions, and those resolutions are reflected in the energy policy. Earlier it was 2009 energy policy, now it is 2019, the most recent one. Those are reflected. So it gives kind of a message to the utilities, or those who are taking up the actual implementation, as to how they should move forward. Usually policies could be even vague, like even our policy in certain places are vague, like the very word I use, affordability. Affordability is a very not that much clear. If it is, say, it should be less than 10 rupees, it is very clear. But policies are not written like that. They are written in a more vague manner. But at times, if there are certain important factors to be emphasized, then policies do that as well. Even our policy has such specific guidelines. For example, certain things should be cost reflective, or even there could be targets given. For example, 100% electrification. Of course, we have achieved that, but there are other targets given in the policy, so that the planners are given direct instructions, direct targets, quantified parameters for them to follow. But in general, we know that policy is only a guideline. Okay, it's not a law. It is something which gives direction, which helps the planners to actually move forward in their planning process. But when there are certain, requirements, these policies could be slightly I can't say violated, but, slightly, we can deviate from these policies slightly because there are certain provisions and they are not specifically, mentioning certain numbers. So we can have different interpretations for that. Okay, and for good and for bad, we can have different interpretations of our policies. So that is why we need something beyond policies and something beyond strategies, which is actually the utility plan. And unfortunately, time to time, we also come across these additional guidelines, like, sometimes they are the election manifestos, which become almost policies, or we think that that is a policy and then try to follow those. But actually there is only one policy, which is the national energy policy, and the planners will be actually following these, but certain confusing signals are coming, which makes the planning process even more difficult, because sometimes the proper policy is there, but these other messages coming are contradictory to those written policies. In that sense, planners find it very difficult to implement one policy. Anyway, so that is the context of national energy planning, or the national policy context. But when it comes to the utility, or today's main topic, utility planning perspective, it is very simple. Say in our case, it is Ceylon Electricity Board, or in any other country, the planning process, the objective is the same. First, there is a forecast. The planners think or project how much of electricity demand they have to meet in the future. That is the first step. In Sri Lanka also, we do that under different scenarios. What are the peak demand expectations and total energy requirements expected in the future? For perhaps 20 years, we forecast this under different scenarios, growth scenarios, energy efficiency scenarios, and so on, and identify what are our expected demands in the future. And then second step is try to identify the best combination of generation technologies and generation capacities to meet this demand. So that is the second step. And then the third step is the network, the transmission network, the distribution network. The planners will plan on how to take the generation to the expected demand using these wires. So that is the next step of planning. Plan the network so that the demand and the supply can be met. That is the broad, process of planning used in utilities. The utilities' sole objective is this, okay, just to meet the forecast demand, and for that identify the generation and also the transmission and distribution requirements. So even in CEB, we have these three processes happening: the demand forecast and the generation planning done by one unit, and transmission planning done by another unit, and distribution planning done by other distribution utilities. And of course, LECO plans its own distribution network expansion to meet the demand and the supply. Okay, this is the simple utility planning perspective, or rather what the utility planning all means. But then the most important factor of this is the generation planning. And for generation planning, as I mentioned, the generation planning objective is to meet the forecast demand. Very simple. Somehow it should meet the forecast demand for, say, 20 years ahead. The forecast demand has to be met. While meeting this requirement, while meeting this demand, the generation plan should also fulfill many other requirements. Okay, one requirement, as I mentioned earlier, is the energy policy directive. Okay, for example, there are many resolutions, many decisions, either directly or vaguely mentioned in the energy policy. For example, 20% energy by renewable energy by 2023 could be one such policy directive given to the planners. So while meeting the demand forecast for the future, the planners, the utility planners, the generation planning people in our utilities should make sure that the decision taken by the people reflected in the energy policy, that 20% of the energy should be from renewable energy by 2023 has to be met. Okay, so there is very little provisions for the utility planners to move away from the policy when it is so well spelled out. So once we agree through the policy that, okay, this is what we are doing, utility planners will comply with that. Okay. And also, if there are any other guidelines, as I mentioned, there could be other guidelines, like there could be cabinet papers, which also should be taken into consideration. There was a recent cabinet paper, not that recent, but cabinet paper that is applicable for generation planning. So those have to be taken into consideration when doing that. And also, we can't, as planners, nobody can violate the laws of the country. So national laws, again, have to be complied with. Regulatory directives. As the regulator of the electricity sector, PUCSL has given certain directives, have issued certain guidelines, codes. For example, what kind of spinning reserve, what kind of reserve capacity, loss levels should be achieved by the power systems, or the reliability that should be maintained, loss of load probability that has to be maintained. So all these are given as codes or guidelines by the regulator, which again the utility planners have to meet. And then the planning done by the utilities also follow a set process which is written in the planning code. So for example, CB has its own planning code, and they will follow this code, which is very well written and very well explained. And anybody who comes to, as a planner in a utility will have to follow this, not his own method or not his own the ideas about we should take more of this and that, but should follow the process written in the planning code. And then there are, whether they are written in the planning code or not, there are certain technical requirements, the network requirements that have to be met in the planning process. For example, the stability requirements, the standards that have to be met. Certain practices of the network or the power system may have certain ways of being operated. So for that, for example, when there is a sudden increase in the demand at a particular time of the day, there would be certain requirements to be met to make sure that system is stable. So those practices will have to be continued, and certain experiences gained by the utility by running the system for so many years will also come into play when they plan for the future. So these are not, common knowledge to all of us, but then the utility planners will have all these combined together when they are doing the plan. But again, we should understand another thing. Now, utility is not the government. Utility is another organization. The organizations, we have agreed, theoretically we know that they should ensure that the institution is sustainable. Okay, because unless they sustain, the process will not continue. The process will also fail. The meeting the demand, for that the utility should be there. So the financial sustainability of the institution is also important. To what extent, I don't know, this planning process actually has provisions to take this into consideration, but ideally any planner should make sure that necessary revenues are generated and necessary, the costs and benefits are considered when they are planning the network. Otherwise, while meeting all these, if the necessary, the revenue is not going to be generated, then again, that's a problem. If the costs are going to be very high, then again, it is a problem. So I think utility planners should also think about the institutional sustainability in preparing their plans. And though directly or indirectly, what is reflected in the plans of ours is also to make sure that the institution is also kept alive while meeting all these conditions. Otherwise, it's it's not going to help anybody. But in addition, these are the mandatory requirements or the essential requirements utilities compelled to follow. Okay, these things are almost mandatory requirements. Whereas, in addition to these, unless these are already specified by the the policies and so on, still in utility planning there is a requirement to think of the environmental and social impacts, the concerns of the people or the public opinion itself. Even outside these, still people like us, people like SLEMA members would have different opinions, reasonable opinions. So the utility planners still, of course, they are not really compelled to follow all our views in their plans, but still give some consideration to these through the public consultation process, and then try to adjust their plans to somewhat, not to say satisfy, but at least give some consideration of our views as well. So I think this is the process wise, this is quite reasonable. Of course, we can discuss, whether there could be any improvements to this, but this is what the planning process actually follows. And when it comes to the actual selection between conventional versus renewable, in the planning process, there is actually no such distinction. Though I mentioned that, okay, in our minds it is very clear what is renewable, what is not conventional, what is non-renewable. But in the planning process, it is not taken as such. These are renewables and these are non-renewables. So these are our favorite ones and these are others. Actually, in the planning process, what happens is each technology is identified or associated with certain attributes. These attributes are the capital cost, the operational cost, the sustainability or the availability of the resource, what kind of resource is there, whether we have that resource, the maturity or the complexity of the technology available. Okay, for example, of course, all these, the factors about, the affordability and all these will be there with, say, nuclear power. But if the technology is not available for us, then the planners will, consider it differently. So that is one thing. And the gestation period, that is how long it will take for a particular technology or power plant to be developed, and what would be the lifetime, and the environmental and social impacts, and also the performance of these different technologies in the grid when running in synchronism or when running in parallel with the grid, how it will behave. All these factors, whether it is renewable, non-renewable, conventional, whatever it is, these are the things the planners would be looking at. Okay, these are the things which are inserted into the software. Not saying that, okay, this is renewable, this is going to be private, this is going to be government funded. No such thing. It is actually these parameters, the capital cost, the operational cost, and so on and so forth, which are the real parameters used in the planning process. And finally, what you get out is the generation plan, which has selected the optimal combination. Optimal in the sense economically optimal combination of technologies which meet all the planning criteria. The planning criteria I mentioned over here, all these requirements, there would be a particular combination which is the best combination while meeting all the requirements. Actually, what is coming out of our planning process. Okay, ideally this is what it should be coming out. I think that is reasonably done, and this is how it should be done. So now our concern, still we think that renewable energy is not favored enough, or renewable energy has a low uptake. Not enough renewable energy is coming out of this machine. The planning process is not giving results which shows enough renewable energy. But we know that all other countries are talking about renewables. How come our machine is producing some other results? Maybe, I don't know the reasons, maybe further reduction of capital costs. Like in the future, there would be further reduction of solar power, further reduction of batteries, which would supplement solar power, or maybe future costs of wind are expected to go down, but maybe that is not considered in the planning process. Or the long-term operational cost, especially considering that there is no fuel cost, maybe the renewable energy is in the process of, how this, the real-term analysis is done is that, future exchange rate variation, the real cost of fuel in the future may not be reflected properly in the planning process. Okay, that could be, I'm not saying that that is the case, but that could be one of the reasons of, conventional energy still being, being selected over renewable energy. Or there could be another reason, lower cost of externalities. That is that, these are the arguments we hear every day, that conventional energy, because of their emissions, because of their other polluting emissions, are doing more harm, though they appear cheaper, is actually in the longer run, if you consider the entire economy, entire health and other factors of the people, is causing more damage. And perhaps renewable that is not doing that much of damage is not being properly evaluated based on this externality cost. That is another factor that is brought out, and that could be a reason where renewable energy is not properly evaluated. But on the other hand, in reality, though we think that okay, renewable energy is cheaper, maybe in economic terms, actual monetary terms, cost of renewable may still be higher. Actually, if you go back 10 years, this argument was more or less the same, even 10 years back. Okay, like renewable energy is cheaper, and still we choose conventional energy, was an argument we heard even 10 years back. That is because we think that okay, what we know is the ultimate truth, and that the others don't know about all this. But the thing is, these conditions could change over the period, over the years. These things could change little by little, but that does not mean that when you collect and consider all these factors, it's not a simple process followed, and the results coming out of this may not be what we foresee from our simple understanding. There could be many other complexities involved in this calculation, which for example technical realities, for example environmental, for example the network related constraints, which really shows that having renewable energy may not be the cheapest option for the country. Okay, and the technical performance of renewable generators itself may limit their use, because as of now we know that there are certain technical issues which are causing additional cost to the utility. So when you collect all these issues together, maybe the overall cost is higher, or maybe the power quality generated by renewable energy is not as good as conventional generators. I'm just listing out certain reasons that may be why we are not seeing enough renewable energy coming out of our planning process. Or maybe the adverse impacts of renewable energy on the financial sustainability of the institution. I mentioned that the utility planners should also look at their sustainability of the institution. That is one of their key priorities. If I am working for a company, my objective should be to sustain the company as well. Otherwise, if the utility does not generate enough funds to keep it going, then the entire sector collapses. And actually, this is also one of the reasons that okay, certain technologies, certain schemes are not favored in the plans, because that causes damages, or that causes issues to the financial sustainability of the utility. if I take the example of, say, cost reflective tariff of wind, of course, that was a very good technology, but then the tariff offered was higher than what CEB could sell this electricity for. And then what is happening is this erodes the utilities revenue or the profitability, and then gets into a negative cash flow. So for example, if we look at the solar rooftop tariff, that tariff may erode CEB's revenue, and then that could be one of the reasons why CEBs or the utility is not directly moving forward with these schemes. So the problem here is we think that, okay, it should be a straightforward process, but when you consider all these factors I have listed here and all these factors we are putting in here, the final result may not be what we are expecting. Okay, so how can we improve this? How to ensure that the proper selection is done between conventional and renewable sources? Because it is nothing more than kind of a not knowing others' perspective, not knowing what are the other factors. We think that what we know is the only factor related to this issue, but there are many other angles. And once we get to know all these angles, we will start appreciating why certain results are so. Okay, for this, how to improve this entire process, sound approach method should be used in the planning process. So if we have a problem about what is being used for the planning by the utility, which may be the reason that, okay, enough renewable energy is not taken up at the moment, then we should not actually, discredit the results, but actually try to improve the process. If we think that the future benefits of less fuel imports is not properly reflected, we should discuss about that process and try to improve that based on common consensus. And also we should get the best people, train and assign the experts for the planning process. That is, like, we all are not having the expertise to do the planning. So the proper people have to be selected, trained and used for the planning process, because it is for the entire country. Okay, use accurate parameters, assumptions, inputs for the planning process. If we put in garbage, we will get out garbage. So as much as possible, we should make sure that all the assumptions, whatever the assumptions put in to select these different technologies, should be as accurate as possible. How do we know that? Be transparent on the planning process inputs and results. So the planners ideally would be spelling out what are the inputs and assumptions taken, so that everybody knows these are the reasons that we get certain outputs. And improve the trust and effectiveness of regulation, so that this process is properly monitored and necessary corrections, necessary challenging, necessary kind of revisions are incorporated into the process, so that overall everybody has the trust about the process. Okay, for that it is essential that the regulation process is also improved and properly used. And finally, now this is a small country and we have one objective of, okay, planning for our energy demand or the electricity demand, and we have done everything possible by selecting a proper plan and improving it and selecting the best people, because say these people who are doing the planning, if I am doing the planning, I am there because I have been selected by this society to become an engineer and do the planning for the country. Okay, once I have been selected for that, then not everybody else can't be coming up and saying that, okay, you can't do that, because that is what we have selected. We have selected doctors, we have selected engineers, we have selected planners, we have selected regulators. Once we do that, then let them do that. So that is also very important, that we try to improve as much as possible the process and everything we do, inputs and outputs. And once we do that, let's rely on those experts to come up with the best plan, so that once they do that, even for that matter, even politicians, even the medical experts, whoever we have selected to do a job, once they do it, policymakers, once they do it, let's keep our trust on them, so that whatever the results they give, we will follow that. If we have concerns, let's go to not the results but to the process and see whether the process has been followed. The process can have more improvements, but apart from that, let's trust on this process. That is what I wanted to highlight here, especially not being a planner from the utility, but only a person who is outside the utility and also outside all other organizations, just seeing what is happening. I think this utility perspective, how utility would be looking at this planning process and what are the reasons that we see certain results coming out. From my angle, today I present, but I would like to have your views now. Okay, I think we have got questions and maybe there are challenges, but let's discuss everybody's ideas as much as possible. And see, not to agree on anything, like we still will have a lot of disagreements, but at least let's try to get more views from others so that we are better knowledgeable on what different angles different people have on the same issue. Okay, so now I think actually that is what I wanted to present today, and I would like to invite the audience to bring out their views. Actually, perhaps you may have questions which I could answer, but I would rather prefer you all expressing your views also within the given time, and then kind of educate everybody else of certain things that are relevant for this topic. And Rasika or Harsha, can you take up the questions session?
Yes, thank you, Dr. Amila, for the very interesting presentation. We learned quite a lot from your presentation, and we have two questions. One from Mr. Namis Musafa. He's asking, transitioning into green economy under post-COVID recovery from recession, while continuing on decoupling from GDP growth with specific energy usage, energy intensity, under a sustainable development context. When world start about zero emissions by 2050 and 1.5-degree climate, aren't we in a serious dilemma? What is your way out? What is the way out? He's asking.
Namis, thanks for that question, and I think that is very relevant, and also many of us may have similar kind of sentiments about this, but I am a bit different on this overall scenario about what we should be doing, because either with the pandemic or not, either with our economic distress at the moment or not, I think my personal view is we should not be changing our strategies, or we should not be changing our process of planning, because it was robust and we did not have serious defects in our planning process into the future as to meeting the demand. And if there are certain changes in the demand, that would be reflected and of course addressed in the planning process. But I personally think this is outside our sector or the planning or for electricity, that what will happen in the longer term to the economy, and how we should be correcting that. But in the planning process, purely going by the planning process, it is simply a feedback loop we are addressing here, where any changes to our economy, to our the forecast demand, or to the commitments we have made would be reflected, and there would be a certain time lag, but then the electricity sector would be reflecting that in their plans. So in that sense, I think for the electricity sector, we should not be seriously concerned of the serious changes that is happening, because this is more of a electricity sector is a quite a kind of a rigid and with a high inertia it operates. So in that sense, I think we can move forward without having a serious deviation from the directions we were heading.
And Mr. Tilina Guluvita raised hand. I can let you speak if you have a question. Mr. Guluvita. Yes, you can raise your question.
Yes. First of all, I'd like to thank Dr. Amila Wickramasinghe for the very interesting and very unbiased presentation regarding this issue in the sector. I'd like to, first of all, my question one would be a little amendment to his presentation content. You mentioned that CB may erode their revenue by paying for rooftop solar. So I'd like to propose to correct it as CB has actually eroded their revenue for the past couple of years. They have been paying 22 rupees a unit for rooftop solar while earning only on average about 19 rupees and 50 cents a unit. So actually CB eroded their revenue. And question number two, you mentioned that we should put proper people in proper places where policy decisions are taken and policies are made, but does it actually happen? Because for example, if you take the PUCSL, about 10 years ago, actually there have been people who are experts of the sector and who had experience, several decades of experience heading those positions. But now it has not happened. If you take the last 10 years, there have been fresh graduates who are directly put into the directorial positions in the PUCSL, and I don't know how they actually make those decisions, because we make a 20-year generation expansion plan in CB, but it takes around 2-3 years for us to get it approved. And they don't just approve it, they completely change what is in the plan, and they send back whatever plan they want to implement. So there's this question as well. And what about the very impractical plan of having 100% renewables by year 2030? Those are my questions. Thank you.
Thank you, Tilina. Let me first answer the first question. Perhaps yes, the indenting or the loss you may have occurred as CB due to solar rooftop. Yeah, there could be, because of the reduction in the cross subsidy on one hand, and also even net plus, there is a higher tariff. But on the other hand, there could be benefits in the longer term, like this is a long-term contract, and we have seen the cost of generation going up every year, at least slightly because of the currency and so on. So now the rooftop solar, the contract is for 15 years, and say even in the 15th year, there would be like 1550 rupees, paid to the paid for the generation. So perhaps in the longer term, I don't know, I have not done the analysis, but in the longer term, it is not assured that, okay, it will be a negative cash flow. Maybe that would give positive benefits or the benefits to CEB in the longer term. So in that sense, I think planning is like that. Like, maybe initially we may incur a lot of losses, especially in terms of renewables. Initially we spend a lot of money, but then actual benefits would come later on. Okay, so I think they are, of course, the tariff could be high or could be, reasonable, but unless we see the full picture, the long-term picture, we will not know whether it is actually a problem. But of course, for CEB, with its current, the financial position, may be more interested in the immediate future, because you have to survive today to, think of tomorrow. That is important, but I think it is not a direct, loss as such, because when, especially in terms of renewable, you have to absorb some loss in the initial periods to get the benefit in the latter part, isn't it? That's quite, common for renewable, which I did not actually mention, but I should have. Whereas conventional energy, maybe it is cheap at the beginning, maybe diesel generator would be very cheap, but then you have to spend it all throughout. So that balance would be there. But I agree with that, your point, certainly, that we saw that there is a kind of impact, financial impact to CEB. The second point about the experts, or the expertise of PUCSL, I think one of the reasons of this, the discussion today is that we should actually, this is the, we are a very limited, expert community here, engineers, and whatever it is, it's only us we have in Sri Lanka. So we have to manage with this. We have to give opportunities to the youngest, like, especially we are seeing that the younger people are much better than us. Okay, of course they don't have the experience as such, but they are smarter. So younger they are and becoming more experienced, it is better for us, because we don't need all the people to take all the decisions. That is enough in the political domain. So in our field, it is good to have young people taking important decisions. So, but very important that they have the experience and they don't challenge unnecessary things. So I think for that, we have to respect others' views. I think that is not what is happening in our sector, that we think that what we know is the correct thing. But I think in other countries, people respect the others' views more than us. Because of that aberration, that the resistance to comply with others' requirements is, we have that problem. So one of the objectives of today's the discussion of the energy forum is that to understand that there are many views. Some of the things they tell could be true, some of the things they tell may not be correct, because they don't see our views, they don't see others' views. So it's very difficult, but we should understand that more exposure we get, better we become. And it is, whatever it is, it's the few of us who are in the country. So we can afford to fight and somehow move forward as much as possible, while meeting this primary requirement of meeting our energy requirement. Third one, I may not have an answer for that, so I will skip that. There is another question by our Vice President Kamal. Is that Mr. Kamal Ileperuma?
We will see. Kamal, you can speak. Is this Mr. Kamal Ileperuma or someone else? You can speak if you wish.
Can you hear me?
Yes.
Hello.
It's Mr. Kamal Ileperuma nonetheless.
Yeah, right. Yeah, Amila, it was a nice presentation. But yeah, in your presentation, you have mentioned that the renewables do not come as passed out candidate from the planning process in Sri Lanka, but other countries do like. But do you think really that because the amount of renewables already in the system and what possible probable or the candidate plans with renewables, and considering all these system constraints, operational constraints, and stability, reliability aspects, and all that, and again the power quality and all that, I think that we have already gathered, absorbed quite a amount of renewable energy in terms of energy only, but there are other aspects as well, as in terms of operations and all that. So, what are the possible candidate renewable plants? Do you think that that if you think that will come out from the planning process at the current context?
First, I think, thanks for the question, Mr. Ileperuma. So, firstly, I should mention this as well, that say compared with the planning process we have in Sri Lanka, I have been, involved in planning in the region, and also I have seen Australia and some other countries. So we have a very, sophisticated and comprehensive plan compared with many countries. You wouldn't believe most countries actually in our region just rely on, say, JICA master plan. Most countries use JICA master plan as the Bible and don't even know how the the plan is prepared. Okay, it's really pathetic how some countries really plan their process, and some countries like in Australia there is no such long-term generation plan, because the demand is not growing and such requirement is not there. In that sense, the planning process we have in our country is very good. Okay, as the first point I should mention this, that it is very good. It may not be to the satisfaction of everybody, but it is far ahead than many other countries. And then say, if we don't get enough renewable energies selected out of our planning process, okay, I don't think it is a problem of the process or anything related to who it is, who is using this process and so on. It is the reality. It is the reality. But then we can see how that can be improved by improving the technologies and improving the parameters we are using, assumptions we are using, by having a proper discussion. So I think even now in Sri Lanka we are doing that, assuming or checking out what could be the improvements that can be done to integrate more solar rooftop to the country, integrating more batteries so that certain variations can be absorbed, certain, like what you have done with the Mana wind project, forecasting the demand so that more wind, or forecasting the resource so that more wind can be absorbed. So every day we improve. Earlier, maybe 5 years back, what we thought is possible as renewable energy penetration have now increased to a much higher level. Maybe say the 100% renewable energy, which at the moment we think is what Irina brought out last, which is not realistic for our mind at this moment, may be realistic in 5 years time with technological improvement. So as much as possible, we should keep an eye on the developments in other countries and the experience of other countries, and integrate those into our planning process so that we get certain results out. But on the other hand, I should also emphasize that we should not be the guinea pig on these, okay? Because we are a poor country, we have other priorities. We should not be spending our little resources to innovate. Unfortunately, that is the situation, to innovate or try out new things. Let the richer, that's my personal opinion, let the richer countries do those research, do those pilots, do those tests, and show us results. We shouldn't be ashamed to just follow those, because we have other priorities. As a poor country, we need our kids to be fed, our sick to be given medicine. We have other priorities, so we'll follow the example of others, and others are doing certain things. So let's keep an open eye on those developments and feed in those parameters to our process, so that we will also automatically get more and more renewables out, if that is the the favored that has the capability to be integrated more.
You have partially answered the question by Mahesh Ratnayaka. He's asking, do you see major differences in planning process adopted in Sri Lanka and Australia? And incidentally, one of the experts we have, he has settled down under Australia. The very few of us, he said, now he's away from Sri Lanka, Dr. Amila himself. So he's maybe in a good position to answer that question. But before that, Dr. Prinath Das is here. A warm welcome to you, sir. We are very fortunate to have you here amongst us. He's asking, taking into consideration intermittency and stability issues, is there a limit to the percentage of renewables that can be accommodated? Is the government target of 70% technically feasible? He's asking those two questions for the moment.
Yes, thank you, sir, for joining us and raising this question. And of course, I have studied particularly this area for my PhD, but still I would not be able to say that, okay, this would be the limit, because there are many enabling technologies coming up. Simple example is batteries, but even the renewable, the inverters themselves, say certain other technologies like synchronous condensers, many other technologies, grid enabling options are there, which little by little improve increase the penetration levels possible of renewable energy. So at this moment, if we say that, okay, this is the maximum limit, it would be wrong. Even say 100%, of course, as Dilna said, it looks really, ambitious. 70% even is ambitious, but so smaller systems are already having higher penetrations. We were involved in a project in a Pacific island. They were going for 100% renewable, and there is one project in Australia, a mining project. They are running on solar. For these are nothing compared to the size of Sri Lanka or the power system of Sri Lanka, but higher penetrations are becoming a possibility with batteries and other technologies. So in that sense, it looks dangerous at the moment with the common the knowledge we have, but I am reluctant to say that, okay, there would be a limit, or these are not possible, because so many things are changing. So in that sense, I am hopeful that we will be able to achieve these targets, but I am really disappointed that those who set the targets and those who support these targets think that the others are, kind of against these without any reasons. No, there are very valid reasons. Running a power system with such huge intermittent loads, you wouldn't imagine how difficult it is. The issues, the voltage issues, the frequency issues, the inertia issues, so many issues which are not resolved with the current technologies. So in that sense, you should appreciate the concerns of the power system engineers about being skeptical about these targets. But on the other hand, there would be improvements once they come in. Certainly, power system engineers should and would integrate these and improve the integration.
And you have a minute to answer Mr. Mahesh Ratnayaka on the differences between Australian and the Sri Lankan.
Yes, certainly, Mahesh. Here we don't have at least 5-year plan even. It is just replacing existing ones with more cheaper ones. That is also in the energy market. That is no plans, no commitments given for any generator. You would see that certain power plants are there only to run for 1 hour for an entire year. That is because they are not needed and they have been built, and subsequently other power plants have come, replacing the need for the more expensive ones to be run. So it is, I can't say a chaos, but quite a risky and uncertain energy market here. And still people take that risk without any guarantees, put up power plants, and when their need comes, they charge very high prices, and still works, make sure that the business model gives them enough returns, but nothing compared to what we have in Sri Lanka in terms of very long-term plans. So it is you wouldn't believe that it is like, you know, very short term plans they have here.
And from our own Loshan Palyangoda, he's asking, are we as a country too early for a larger wind and solar energy share? Because investment against return for investors looks attractive, but for distributor, it's a loss. So similar concerns, if you may try to answer.
Perhaps, you know, we had a similar session regarding the Mana Wind project, and we know that the cost of Mana Wind project, the unit cost of generation is very low. Of course, two things, renewables. One is the technology with intermittency and other technical issues. The other one is the cost issue. So we know that solar and wind prices have come down so much that, of course, without, you know, having serious cost concerns, we can integrate large renewables. So that is one thing. Say we may have very high renewable energy as well, but we have cheap options as well, both solar and wind. So that is a possibility. But the technical issue, yes, as I mentioned earlier, at the moment, going beyond, say, certain levels, as Dr. Prinath asked, you know, even beyond 30% for Sri Lanka, I think would be really dangerous. Even at the level we have at the moment is very high. So we may go a little bit beyond this, but not far. Unless we improve the system, the other facilities we have to make, you know, the balance these renewable and non-renewables without compromising the system security. Unless we do that, as you say, Loshan, just adding more and more renewable, intermittent renewable may cause a lot of problems. But saying that there would be technologies, there are technologies which we have to bring in to accommodate these large integrations of wind and solar.
And Mr. Jasa Ismat is reminding us the cost of solar rooftop, although it is 22 rupees for the first 7 years, it's 15 rupees and for the remaining 13 years. Levelized cost of electricity from solar rooftop is actually 1982. So 19 rupees and 82 cents with I think 10 point something discount factor. So we make note of that. And there's another question from Mr. Tarandu De Silva. I hope he's from LECO. Thank you for the informative presentation, Dr. Amila. Isn't it better to keep aside financials of CEB for a while and analyze the overall impact of solar rooftop and other renewables of our country as a whole in the planning process? Once we obtain the optimum plan, considering all aspects, including operational constraints, we can think about the financial sustainability of utilities, which is a secondary process, as I feel. That is coming from a utility man himself. How do you
That's right. Very valid, very good question. If you know, in an ideal world, this should be the way utility planning should happen. But this is not an ideal world or an ideal country. And what happens is we plan ideally, and then get you know, the implementation is entirely chaotic, and then CB finally runs into huge deficits, debt, and then that erodes the sustainability of the entire sector. So we may be looking at supplying electricity for 15 years, but the way things are happening, just going by the economics, CEB may end up not having a CEB at all. So utility, I think, has the responsibility to make sure that on behalf of all of us, CEB engineers should make sure that their institution is also sustainable. They should fight, get the tariff from us. Of course, we don't like to pay the tariff, but they should somehow get it and make sure that that organization is there. If they don't invest on proper investments, proper lines, generations, finally, that causes a lot of problems to our power system, our electricity supply. So we expect CEB to look after their institutions and also LECO to look after their institution so that the long-term investments can be made for the benefit of us. Okay, that is why I said nobody thinks that, okay, other than economics, they should be thinking of anything. No, it is very important to make sure that utilities sustain. To do this, otherwise, what is the point of planning and doing everything for the future if, you know, even small maintenance can't be afforded by the utilities? And finally, you will have power plants running for 20 years, but you can't give electricity because you can't replace the fuse. So I think both are important, and something we should understand as the public is that utility financial strength is most important to make sure that we have cheaper electricity in the longer term. Okay, if they don't have money, they will not invest and finally end up having a lot of diesel power as what we are having at the moment. So it is our obligation to make sure we give the proper tariff to the utilities so that they will do the proper, they are not going to take that home. They will invest and make sure our long-term tariffs are lower than what we are having at the moment. It is totally opposite what we are doing and what they are doing.
I think it's getting very late in Australia, so
Yes.
sorry about that. But there's one last question, hopefully, from our Senior Vice President, Mr. Chamila Jayasekara. Chamila, you can speak up.
Yeah, thank you, Dr. Amila, for the detailed, comprehensive presentation. And you said in this Q&A session, we have a good planning process and sophisticated approach to planning compared to many other countries. It is very advanced and sophisticated. Yes, sure, it is well accepted. But with respect to this very topic, we are trying to input some firm sources on the one hand. So I mean, when you say conventional sources, those are very firm sources.
Mm.
But when you say these renewable energy sources, this availability of the resource is it depends on time. So here you are trying to analyze two completely different inputs, because one input is you have firm with respect to time, but the other input, renewables, it is varying with time. So
Yes.
so my viewpoint is you should have a sophisticated planning process or the software to do the analysis with respect to time. For instance, solar, you have to analyze considering different sorts of the day, and for the wind particularly, you have to analyze considering different seasons of the year. So in that respect, I think this planning process is not that sophisticated.
Chamila, the situation has improved very much over the years. Earlier we had only WASP, and now we have much more sophisticated software, which actually can look at the time series analysis as well. May not be the perfect one, but certain variations, intermittencies can be captured. And we do that test as far as I know, and when I refer to the generation plan, they have used software which are capable of looking at these impacts of intermittent, not firm generation. And the earlier complaints we had about only looking at the load duration curve and not the time series data is changing. So in that sense, I think CEB has moved forward in the correct direction to analyze the impacts of these renewable energy and the more novel technologies through the planning process. The process has also improved. Maybe there are issues, but still I think compared with maybe 5-6 years back, now CEB is using more sophisticated techniques to analyze the impacts.
Thank you.
Okay, thank you, Dr. Amila, for keeping up so late into the night. And I will ask Mr. Rasika Gamage. Rasika, are you here?
Yes, thank you, Dr. Amila, for the very informative and detailed presentation on the timely topic, actual generation planning perspective. And thank you again, Dr. Amila, and dear colleagues, participants, thank you very much for your patient participation. And we'll be meeting up again in another similar forum, but under a different topic in the near future. Thank you very much. We'll wind up the presentation now. Good evening to you all.
Thank you, everyone. Thank you for being with us.
Okay, thank you.